Hi everyone. In this video, I'd like to talk about a claim that says let A, B, C be integers, and if A divides B and A divides C, then A divides B times C. So first of all, let's just take a look at what this means, and then we'll dive into the proof. So I'm just going to say, A, B, C are integers. So what does that piece mean? What that means is we're looking at, numbers like A equals 2, B equals 6, C equals 8, for example. And we're not looking at things like 2.4 or 1/2 or stuff like that. We're looking at actually integers. And then A divides B. So this says A divides B. That means that A goes into B perfectly. So you could say, 2 divides 6. 2 goes into 6 perfectly 3 times, in fact. And that's what we mean by divide. In fact, the definition of divides says that A divides B if and only if B equals A times K for some integer K. And we'll use that definition in a minute. Similarly, A divides C, then A must divide the product. So I do have a little example here. If A equals 2 and B equals 6, we can say A divides B. In our example here, 2 divides 6. A divides C. Let's see, 2 divides 8. Yes. And so what this claim is saying that A must divide the product of B times C, which in this case, 6 times 8 would be 48. 2 divides 48. So this exploration is just to wrap your head around what are they even talking about? What does the notation mean? And now our task is to go in and prove this for all integers that have these properties. It's not enough just to use the 2, 6, and 8 and claim it works for everybody. Okay, so for my proof, I'm always going to start my proof with the word proof. And I'm going to state my assumptions right away. So I need to assume this information about A, B, and C. So we'll say let A, B, C be integers. That was pretty much a copy paste right there. So we're just restating those assumptions. And for a direct proof, I'm going to assume everything that's between the if and the then. So I'm going to assume A divides B and A divides, that should be a C. A divides B and A divides C. Now, our goal is to show everything that comes after the then. So this is my goal to show. All right, so that's what we're hoping to do. And let's proceed with what we have as far as information, and then if we get stuck, we'll start working backwards. But let's start off with what we know. A, B, and C are integers. Great. We know A divides B. So let's use the definition of divides. So by definition of that vertical bar, which means divides, there exists an integer K sub 1 such that B equals A times K sub 1. And now we can do the same thing for A divides C. And there exists an integer K sub 2 such that C equals A times K sub 2. So I'm just kind of checking off the pieces that I've used. All right, so far I've got some equations here. All right, so that looks very usable. Now let's see, what is it that we're trying to show? What I'm trying to show, so I could go kind of down here into a dark corner by myself and say, what I'm trying to show is that A divides B times C. And by definition of divides, that's the same as showing that B times C equals A times some integer, I don't care, call it K3 or L or something different. So this is my goal. If I can get to this little equation here, B times C equals A times K3, I've shown the claim. I've met my mission here. So I do know what B equals. I do know what C equals. So let's multiply those together so that we can head towards this equation. All right, so back to my proof, as if I knew what I was doing all along. So we'll say, therefore, B times C, I'm just using these little equations here, B times C. B times C equals A times K1 times A times K2, which equals, now my goal was just to have one A out in front and then a bunch of other stuff. So let's pull one of these A's outside the parentheses, and what's left over is a K1 times A times K2. And I think if you're in the textbook, if you're using WebAssign or something, they might even have the A on the other side. So I'll just put the A at the back because that's how they have it there. Just so if you're trying to work in WebAssign, you can match up what we're doing. But same difference, multiplication of integers is commutative. It doesn't matter which order you multiply in. And now I could let this K1 times A times K2 be some other integer. I don't care what you call it. Could call it L or M or K3. And that's what will show the claim. And so you can conclude by definition of divides, A divides B times C. And then you can erase all your scratches down here as if you never went off in a dark corner by yourself.